A dart is thrown uniformly at random at a circular target of radius 100. Targets divided into 100 rings of by circles of radii 1, 2, 3, 4, 5, 6, up to 100. Each one fully in all circles which are larger. Starting from the center, the rings are alternately assigned a score of positive 1 and negative 1, which with the innermost disk assigned positive 1. The expected value of the score for random throw can be expressed as m over n, where m and n are relatively prime integers and n is positive. Find m plus n. So I'll just draw the diagram here. So here we have actually with any geometry problem, it's very helpful to draw a diagram first. So here, um, we have the target divided into 100 rings. So it's something. It looks something like this. So it's 100. I can't draw 100 rings, of course, but I can draw a relative look of what it looks like. So this is a circle with radius 2. This is a circle with radius 1. And this is the circle with radius 3, etc., etc., right? All up to 100. Sorry for my bad circle drawing. This is also very exact. This is also very under exaggerated. Anyways, this is we must have. I'm going to shade all um scores at side one with positive one with black. Okay, so it's something like this. So circle with radius 1, for example. Um, just pretend this is black. Okay, so it looks something like this, and then we go on and on and on and on, all up to 100. So um, first notice that um the expected that we need to find the expected value of the score, which wherein the expected value is basically um sorry, the expected value is basically the probability of its outcome. So the expected value is basically if P1 is the probability, so the probability of its outcome multiplied by sorry, the probability that you will achieve its outcome multiplied by what's more the prob what you get from probability. So here, and then you just add them all together, all possible probabilities, all possible, basically all possible things that can happen. So if S is the score or to receive and P wants a probability, then it will look something like this. A probability or expected value looks something like this. Sorry for my bad handwriting. All up to P100 times S100. It's because we have 100 grades here. So basically, our score in this problem is positive 1 and negative 1, basically where it alternates for odd and even integers. So here we must have a positive P1 minus probability. By the way, sorry, I haven't defined what P1 and P2, P3, P4, etc. is yet. But let's say probability 1 is for outcome 1 happen, which we will define here as the probability that the dart reaches the hit the circle with hits this spot. Basically the circle with radius 1. And then as it goes on, the P2 is here, P3 is probability of hitting here and etc. etc. Why are we doing this? Because this is basically the definition of what the expected value is. So we need to like define what we're trying to get first in a problem like this. But anyways, um, does anyone have any idea of how to get a probability for each um for to hit each um part of the part of each ring? Sorry, to hit each ring. Basically, yeah. I'll just restate the question. Basically, does any does anyone have any way to find P1, P2, P3 up to all up to P100? Um, okay. Since we're running out of time, I will demonstrate a solution to this, right? You can still comment your ideas though as we go on. So here, the probability of hitting um ring one, which basically is the innermost circle, is 1/10,000, right? Because 10,000 is the area of the whole um target. So that's basically the probability of that. And then you have to subtract the probability of reaching this small section, this section here, which this ring here, which is which is with, wait, sorry, I'll rewrite, redraw it. So that's essentially um the probability of reaching here, right? Which is this entire circle minus the area of this circle. So in this case, yeah, this entire circle minus the area of this circle. So in this case, it's a circle in all of the rings actually. It's the difference in area between circle n plus 1 and circle oh sorry, no, it's not 1/10,000, sorry. The probability is 1/10. So it's actually, yeah, it is 1/10,000, sorry. But it's 1 pi/10,000. But all the pi's cancel out each other out in the solution. Well, so sorry, I will not mention that. Oh, Andrew, yeah, yeah, you're right here. So, but basically, it's n minus one plus n minus n squared for the area of each ring. And where do we start um from this ring here, from this ring here? So after 1/10,000. So this we can simplify this to n squared plus 2n plus 1 minus n squared by the square of a binomial. So we can simplify this basically to just 2n plus 1. And since we start from n equals 0, which is basically just the area of this circle, we go up from there. So we have the area of this region being um 3 pi, or basically a probability of reaching this, of hitting this ring, to be 3 over 10,000. And then we add 5 over 10,000, and then we subtract 7 over 10,000. I think you know where I'm going with this. All the way until we go to, well, when does this end? Well, in the 99th circle, sorry, it's definitely not George scale. But anyways, um, for this last region here, it's a difference between the areas of circle 99 and circle 100, right? So we stop at the 100 squared minus 99 squared pi, or in other words, we stop at sub sub nine 199 over 10,000. Now, so we can just focus on the numerator. It's 1 minus 3. So the numerator is 1 minus 3, sorry, minus 3 plus 5 minus 7, all the way until you add 197 and subtract 199. Basically, you're just subtracting and adding and subtracting alternately the odd positive integers and the odd integers. So um here here um you must you can actually group 1 minus 3, 5 minus 7, all the way until 197 minus 199 here, just like how Andrew did it. Thank you, Andrew. And so we get negative 2, and we just get a constant term. Well, if we group them, then we just get negative 2 minus 2 minus 2 minus 2, all the way until we get to 197 minus 199, which is also negative 2. So we just get a bunch of minus 2s for our numerator. And how many negative 2s, in fact, we get? Well, we can start from, I also start from the end term. I'll just count from the end term. So we got 4 times 1 minus 1, and then we have, basically we're just counting how many groups we have of 1 minus 3, 5 minus 7, etc. All up until 4 times 50 minus 1. So this each of this, 4n, each 4n minus 1 counts the number of groups I like to call them. So since there are 1 up to 50, there are 50 groups. So the numerator here is negative 2 times 50. Yeah? So we still have the denominator of 10,000, and then we does have a probability, or we have an expected value, sorry, of negative 1 over 100. Notice that expected values can be negative if you're basically inherently losing from throwing a dart. So our expected value is negative 1 over 10,000. I'm sorry, negative 1 over 100. And it must be expressed as m over n, where m and n are relatively prime integers, and n is positive. So this is our last two here. So since the expected value is negative 1 over 100, the denominator cannot be negative. So the numerator must have the negative number, which is negative 1. So m plus n, therefore, must be 100 minus 1, which is 99. Sorry, which is 99. So sorry for that long talk, but basically, just to summarize everything, we um realized the expected value was the an alternating difference and sum of the probabilities. And then we calculated these probabilities individually, and then notice a grouping pattern where there's just a bunch of negative two. So pre-grouping, right? So thus we found the expected value. Does any